In this video, I'm going to show you how to create an exact clone of the Chrome dinosaur game, and it's actually quite a bit easier than you'd think. Welcome back to Web Dev Simplified. My name's Kyle, and my job is to simplify the web for you so you can start building your dream projects sooner. And in this video, we're going to create an exact replica of the Chrome dinosaur game. And as you can see, I actually already have the images that we're going to be using for this project downloaded. You can get these from the GitHub that's going to be linked in the description below, or you can use your own images if you want. But these are all the images right here we're going to need. And the first thing that I want to do to get started is I'm going to create an index.html file, and this is going to be where all the index code for our HTML goes. So in here, let's just put exclamation point enter to start a boilerplate code. And then inside the body, we need to actually put all the HTML. And the first thing I want to do is I want to create this HTML object, and it's going to be called world. The reason I'm doing this is because I want to put everything inside this world. And then I'm going to scale everything using percentages. And the reason I'm doing that is, as you can see, as this screen increases, you can see every single thing in the game increases in size or decreases in size so that it fits exactly the same. So no matter what screen size you're playing on, whether it's a horizontal screen, a vertical screen, so on, it's always going to give you the perfect play experience. And that's with this world class right here. Everything is scaled off the size of this world. Then we can put everything inside of here. For example, we can put our score, which goes in the top right-hand corner. And by default, we're going to start that out at 0. We can also put the text that you see on the screen for press to start. So we can just say start screen, and inside here, it'll say press any key to start. There we go. And then we can actually put some of the game pieces in. So the first thing we're going to have is an image. And this image is going to have the class of ground. And inside here for the source, we're just going to say images/ground.png. And we don't really need to worry about an alt for this. And we're also going to make a second copy of this ground. And the reason for that is if I click play over here, you can see the game is working and the ground is moving along. And if I don't lose immediately, you'll notice that this ground just essentially repeats. Every single time that the ground is done, it just repeats itself. So if we have two ground images, we can make sure we stitch them up so that essentially every single time one of the ground pieces would go off the edge of the screen, the next one is going to take the place of that ground piece. That's where we're going to have two. And you'll see in depth a little bit more why we do that when we get to the code for it. And the next thing I want to do is actually put the dinosaur on the screen. So it's again going to be an image. I'm going to have the class of dino. And for the source, we want it to say images/dino stationary, because that's going to be the stationary position for our dinosaur. Now, if we save, we can open this up with live server and see what we got. So let's just open that up and wait for it to load for a second. And now, as you can see, we have our text up here. It says 0, press any key to start. We have both of our ground images, and then we have our dinosaur right here. Obviously, it doesn't quite look like a game, so let's actually work on some styles. Up here, I'm going to add a link for a CSS sheet called styles.css. Then I'm going to create that styles.css where we can put all the styles to make this look a little bit more like the example we have over here. So the very first thing that I want to do is I want to select essentially everything. So we're going to get star, before, and after. I just want to set the box sizing here to border box. The reason I do this is because it just makes it easier to size everything. And then I'm going to set user select to none. That just makes it so you can't highlight any of the text on the screen, because right now I can highlight this text here. When I save this, you can see I now no longer can highlight that text. That's just nice because in a game, we don't want to highlight anything by accident. Then for the body, I want to just get rid of all the margins. So we'll say margin 0. And I want to make sure everything is centered. So I'm going to put a display of flex with a justify content of center. I want to have an align items that's also going to be in the center. And then I want to put a min height of 100 VH on my body. And that's just going to make sure everything is dead center in our screen. So when we save, everything is in the center. Right now, it looks a little bit weird because our ground object is so long, but we're going to get to that in just a second. So the next thing I want to focus on is our world. So we're going to say world here. And all I want to do is I want to set the overflow to hidden. And I want to set the position to be relative because everything is going to be absolutely positioned inside this world. And this world object, we're going to resize in our JavaScript to make sure no matter what size our window is, the world is always going to be scaled like we want it to. Now, if we save here, you can see things look a little bit better already because we have that overflow of hidden on here. So now the next thing that I want to work on is going to be our score. So we can come into the score section here. I'm going to set a position of absolute on our score. And then I want to take our font size. I'm going to make it 3v min, just so it's going to scale again with the size of our screen. So as our screen shrinks and grows in size, the font is also going to scale. I'm going to set the right to 1v min. And what I want to do is I want to set the top to 1v min as well. Now, if I just save this real quick, you can see our scores over there in the top right-hand corner of our world, and that looks really good. Next thing we can focus on is going to be our start screen. So we'll say start screen here. It's going to be pretty similar to our score. Again, everything is going to be absolutely positioned. So we're going to absolutely position that. Our font size here, we want to be larger. So we'll use 5vmin. On this one, we want it to essentially be in the center of our screen. So we're going to say top 50%, left 50%. And if we save just that, you can see it doesn't actually look like it's in the center. And that's because it's aligning the top left corner of our text in that center. What we need to do is take our transform and translate it backwards, -50% in both the X and the Y direction. And that is going to allow it to be dead centered inside of our screen. So right now it's essentially in the dead center of our screen. And the next thing that we want to focus on is going to be a class called hide. We're just going to come in here with a class called hide, set the display to none. And that's because when we start the game, we're going to add a hide class to our start screen so that it doesn't show up anymore, because obviously you don't want that text there while you're trying to play the game. Now the next thing I want to do is our ground. So for our ground, in order to make it look correct about the right scaling, what we want to do is we want to set, well, first of all, position to absolute. But we want to set the width to a value that's going to make the ground look the correct height. In our case, the width of 300% is going to look pretty good. So when I save, right now it looks terrible, but if we add a few more classes, it's going to look a lot better. For example, we can come in here and we can set a bottom, because we want it to be on the bottom, of 0. And we can also set our left property. In our case, this left property is going to come from our JavaScript. What I want to do inside of here is set up a calculation where we're going to use a variable, which is our left variable. I'm going to multiply that by 1%, and by default, this left is going to be 0. So I'm just going to come up here and say left is 0. Now this obviously still doesn't look like how we want it to, so what I'm going to do is come up here to our world. I'm going to set the width to 100%, so it spans the full width. We're going to take care of this in JavaScript in a bit, but for now, this is just going to be a placeholder. Now the next thing we can work on is our dinosaur. So we're going to say our dino is going to be positioned absolute, just like everything else. The left is 1% since we essentially want it to be close to the left side, but not quite touching it. We'll give it a height here of 30%. And again, the bottom position is going to be taken care of in JavaScript. So we're going to make sure that's a calculation using a variable called bottom. By default, we're going to keep that at 0. So we'll just say times 1% here. And up at the top, we'll say bottom is 0 by default. Now, when we save, you notice pretty much everything disappears, and that's because everything's positioned absolute. So if we come in here and we just give this a height of like 300 pixels, let's see what that looks like. There we go. We'll actually make that a little smaller. Let's do 200. So there we go. We have our game. It's kind of showing up on the screen. Obviously, these hard-coded values are not what we want. We're going to determine these in JavaScript. But as you can see, some of the sizing and proportions look pretty good. And as we change our height, for example, if I change it to 100, you notice everything shrinks down. When I change it to 300, for example, everything grows. So it looks good and everything is scaling like we want it to. Let's just put this to 200 for now. Now, the final thing that I want to add a class for is something we actually don't have on our screen yet, which is just going to be a cactus. So for our cactuses, they're going to be really simple. They're actually almost exactly the same as our dinosaur. I'm just going to copy it all down. But our left position here is the one that we calculate. So I'm going to copy this calc code, paste it into left here, and make sure this is a variable called left. And up here, we're going to call this left. And we don't even need a default. So we can actually just get rid of that default completely. And then our bottom position here, we want to be 0 because we always want it to be touching the ground. And we want it to be the same height as our dinosaur. So if we add a cactus to our screen, it's essentially going to be left positioned based on our JavaScript code. It's going to be the same height as our dinosaur here, and it's going to be touching the bottom of the screen. Now that right there is all of our styles taken care of, all of our HTML taken care of. The next thing to work on is going to be our JavaScript, which is obviously the bulk of this video. So let's come in here with a script.js. We're going to set the type here equal to module because we're going to be using ES6 modules. If you're unfamiliar with the module syntax inside of JavaScript, I have a full video on it linked in the cards and description. Let's create that script.js file. And all we need to do is add in our code here. And the very first part of code I want to work on is going to be for our world. So when we get rid of these hard-coded widths and heights, you can see everything disappears. I want to make it so that our world scales on our screen size. So we're going to write some code to do that. First, I'm going to need to select our world. We're just going to give it a data attribute called data world. If you're curious why I use data attributes for JavaScript selectors, I have a blog article on it. I'll link in the description that explains exactly why. Now inside of our script tag, we can just close out of the styles here. What we can do is we can select that world element by saying document.querySelector. And we want a query selector based on data world right there. Then we can create a function. We're just going to call it set pixel to world scale. And this is essentially going to scale the world that we have based on how big our screen is. And then we want to make sure we call that function. And we also want to make sure that anytime our window gets resized, so if we add event listener for resize, we also call that same function. So set pixel to world scale. So every time the pixel size of our screen changes, we want to re-update our world to make sure it's the exact size that we want and it scales properly. Now, in order to write this function, we need to create a few constant variables. So we can come up here, we can just say const world size. We'll actually call this world width. And we're also going to need a constant called world height. So you can play around with these variables, but essentially I'm going to say that our world is 100 units tall, or 100 units wide, and it's going to be 30 units tall. This is going to be the ratio of our world. Then inside that function, set pixel to world scale, what we can do is we can essentially use those values to calculate how big our world needs to be based on our screen size. So I'm going to create a world to pixel scale variable. And then this is going to be set depending on if our screen is wide. If our screen is wide, then we're going to be able to have to limit this based on the height. And if it's a short screen, for example, a narrow screen, we're going to need to be able to limit this based on the width. So what we can do is we can say, hey, if our window.inner width here divided by our window.inner height, like this, is less than our world width divided by our world height, then what we can do is we can say, hey, our world to pixel scale is going to be equal to window.inner width divided by world width. So what this is saying is, hey, you know what? If our window right here is wider than our world, essentially, if our window is wider than our world ratio, then we know that we need to pixel scale based on our width, because that's the limiting factor. Otherwise, what we're going to do is we're going to make our scale based on the height. So we can come in here, world to pixel scale is going to be window.inner height divided by world height, just like that. And then finally, we can take our world element, we can take the style, we can take the width property, style.width, we can set that equal to, all we want to do is we just want to take our world width, we want to multiply it by that scale, and it's going to be a pixel value, and do the exact same thing with our height, and this is going to be our height. Now if we save this and make sure I spell height correctly, there we go. You can now see that our game is scaled, and as we increase our browser size, you can see that it gets larger, and as we decrease our browser size, it gets smaller. And the reason that we have these two if statements is because, for some reason, if our browser is really wide, but it's really short, you'll see here that now our game is scaling, so it's cut off on the width, and that's because in order to fit the correct ratios that we have, we need to make sure that if our screen is really short, but really wide, it's going to be scaled this direction, while if our screen is tall but narrow, for example, like this, you can see that our limiting factor is our width, so we're going to scale our game based on that width size. Now with our pixel to world scale done, we essentially have our scaling issue done. The next step is going to be creating an update loop. And an update loop is essentially something that runs every single frame and it updates all the positions of all the things on our screen. So it's going to update our dinosaur, it's going to update our cactuses, our score, and so on. So what we can do is we can just create a function called update, and this function is going to take in the time since we started our program. And in order to call this function, we're going to call window.requestAnimationFrame and pass it in that function. And this request animation frame is a really smart thing in JavaScript that's only going to call our update function the next time that we actually can change the content on our screen. So on a really high refresh monitor, for example, this is going to be called quickly, while on a low refresh monitor, it's going to be called slower, because you can only update the screen so often based on the refresh rate of the browser and the monitor. So now the next thing that we can do inside of our update is actually write out the code for our update loop. Because in order to make it keep looping, we need to call the function a second time. So inside of the update function, we're calling the update function again. So it's going to be constantly calling itself over and over and over again every single time that we can update our screen. And then the other important thing we need to do is get the time between updates, because sometimes your computer might be going through a large workload. And normally it takes 10 milliseconds before each update, but then you have a bit of a hiccup and the next update takes 50 milliseconds. It takes 5 times longer than normal. Well, if all you did was just update the position of the dinosaur, for example, by a static amount each frame, it would move, for example, 5 pixels every frame, even though the time between frames is different. For example, one frame may take 10 milliseconds while the other takes 50 milliseconds. So the dinosaur moves the same distance, but it takes 5 times as long to render out that distance. So it looks like it's moving 5 times slower. That's really bad in a game that requires reaction time and so on. So if we can determine the time between frames, we can actually scale how far we move the dinosaur and cactus and so on based on how long each frame took. So the movement is consistent no matter how slow or fast the frame rate is for the person's computer. Now to do this is a little tricky because this time variable just constantly counts up. So if we console log this and we come over and just inspect our page real quick, go over to the console, you can see this is a value that's just constantly counting up. Essentially, we need to keep the previous value, subtract the new value from it, and that'll give us the actual time since the last time that we ran a frame. So we can create a variable called, last time, for example, set it to nothing to start with, and then inside of our code, we can say last time equals time, and then up here we can get our delta, which is going to be the time between frames, which is our time minus our last time. And then we can print out that delta right here. Now you may think this is exactly what we need to do, but we're going to run into some issues. Like we could default this to 0, for example, and then we can inspect our page, go to our console, and it looks like it's working pretty well. You can see we get these update times here, mostly around 7 milliseconds. But if we scroll up to the very top, you can see this first time is 71 milliseconds. And the reason for this is because the very first time that your code runs through here, this last time is set to 0, but our time is from when the program began. So it's going to be a large gap between the time we actually start the game and when the actual time here is going to be ran. So our time here could be really long, especially if we sit on the start screen and wait to hit start until much later. It's going to be like, 10 seconds or like 10,000 milliseconds. And then 10,000 milliseconds is going to be a huge delta. So the very first time we run update, if our last time is null, for example, we don't have a last time. So if last time equals null, then what we want to do is we of course want to update our last time to be our correct time. So our last time is now going to be our current time. We want to call our thing again to update, and then we just want to return out. We don't want to do any of the rest of our code. We're just going to ignore everything else. Now by doing this, our delta is going to make sure it's always the correct amount, because the first time we call this, when last time is null, it's going to set it to the previous time, and then the second time we call update is when the game is actually going to start. So now if I save and I inspect over here, go to the console, and I scroll up to the very top, you're going to notice even our very first frame here is that 7 milliseconds. And you'll notice some jumping of the frames, and that's perfectly okay. That's why we're doing the code where we're taking into account the delta, because you can see this frame took 20 milliseconds, this one took 62, it took much longer. That's okay though, because all of our code is going to take that into account. Now the very first thing that I want to work on updating inside of our code is going to be the position of the ground itself. So what we can do is we can create a new file. We're going to call this ground.js. And inside of here, we need to select the ground elements. So inside of our HTML, let's go to our ground, and we're just going to add a data ground attribute to it. We're going to add that to both of our grounds so we can select both of them. Then inside of that ground file, we can say that our ground elements are going to be equal to document.querySelectorAll of data ground. So now this is both of our ground elements selected, and we can create a function called update ground, and this update ground function is going to take in essentially the delta. What we can do is we can update the position of our ground by just making it move to the left constantly, and we're going to call this update ground inside of our script here. So instead of logging this out, let's come in here and say update ground, and we're going to pass in our delta. And at the very top of our file, we need to make sure that we import update ground from ground.js. Make sure this is /ground.js. And inside of here, let's just make sure that we export this function as well. So now we're calling this update ground function, and inside of here, we can update the position of our ground elements. So we can just say ground elements.for each ground. What I want to do is I want to take the position that we already have and I want to update it. And doing this is a little bit confusing. There's quite a bit of code that's involved in actually taking a value from a CSS variable, as you can see here, and converting it to a JavaScript value and then converting it back to a CSS variable. And we're going to be doing this all over our code. I'm actually going to create a nice file that's going to be a helper file. We're going to call this update custom property.js. This is going to include a few functions that make updating these custom values really easy. So for example, we're going to have a function called the get custom property. We're going to have another function, which is going to be called set custom property. And then we're also going to have a final function, and this one's going to be called increment custom property. And this one is going to be the one we use the most often because we're probably more than likely going to be updating a value. We're going to add 10 to the left position, for example. So we're going to be calling this increment custom property all the time. Now, in order to actually do these, let's make sure we export these. So we can export all these functions so they can be used in our code. And let's start defining them. For the very first one, for getting a custom property, we need the element we're getting it from, for example, our ground element. And then we just need to get the property we're getting, for example, the left property. And here, what we need to do is we can say return the get computed style of our element. This allows us to get CSS variables. Then we want to get the property value of our prop. And this is going to return to us a string because everything in CSS is a string. We need to convert this to a float because everything we're dealing with is numbers. And then if there is no value, we're just going to default it to 0. So all that this code has done here is it's saying, hey, I want to get the computed style, which means get me the CSS values. I want to get the specific CSS property for our prop we're passing in. I want to convert it to a number, and if there is no number, just default to 0. Now, setting a custom property is similar. We're going to get our element, we're going to get our prop, but we're also going to pass in the value we want to set this to. And here, we can just take the style property of this, and we can call the set property method. The set property method takes in our prop and our value. So this is like -- left, and this would be 7, for example. And then increment custom property just combines these two together. So we can call set custom property with our element and our prop, which of course we're going to pass in here, element and prop, and also an amount to increment by. We're going to set the custom property to the getting of the property. So we're going to say get custom property, which is from our element and our prop. We're just going to add in our incremented value. So here, all we're doing is we're getting the current value, we're adding this incremented amount to it, and then we're setting that value. Pretty straightforward. And that's all of our helper functions done. So now we can actually use these inside of our code. So inside of our ground here, we can use that increment function. So what I want to do is I just want to say increment custom property. And again, make sure we import that at the top here. I want to increment it for our ground element. The custom property is called left, and that's because in our CSS, we called it -- left. So just copy that right here. And I want to increment it by some amount. This amount, we know we need to scale based on our delta. So we're going to say delta times. We also need to scale it based on some speed variable, which we're going to call speed. And then we want to make sure it moves backwards. So we're going to multiply this by -1. So up here, let's just say const speed is equal to 0.05. There you go. And this is going to increment our ground position and essentially move it to the left every single time we call update. So now if we save, you're going to notice nothing is on our screen. That's because it should say update custom property.js. Now when we save, you can see our ground is moving to the left. That looks really good. But you'll notice in just a few seconds here, we're going to reach the end of the ground. And obviously that is not what we want. We don't want the ground to have an end to it. We want it to constantly loop back. So what we can do is we can write another function. This is going to be called export function setup ground. And this setup ground function is what we call right when we start our program. And all I want to do here is call the set custom property method, which we're going to make sure we import up here. And I want to take the custom property for our ground elements. I want to get the very first one. And what I want to do is I want to set that left property, and I want to make sure it's set to 0. So we're going to be setting the left property of the first ground element to 0. Then for the second ground element, I'm going to set the left property to 300. The reason I'm doing that is because in our styles here, you'll notice we set the width to 300, and this left is a percentage. So if the left property of our second ground is set to 300%, then that means the left of our second ground is exactly where the right of our first ground is. So they're going to match up with one another. So it's going to give us one ground element that's twice as long as a normal ground element. Then in our update, what we can do, because you'll still notice as this runs through, eventually we're going to run out of space. It'll be twice as long, but we're going to run out of space. Let's just make sure that we call this setup ground here. We're just going to do it at the top for now. Just say setup ground, and we'll import that. Import that up here. So you'll notice our ground moves to the left, and it's going to be twice as long as our normal ground, but still it's going to run out of space. To prevent that, what we can do is we can create an if here that says, get custom property. So we're going to get the custom property for our ground and for our left property. And what I want to do is I want to say, hey, you know what? Is this less than or equal to -300? And what this means is saying, hey, has our ground moved all the way off the edge of the screen? At -300, that means the right side of our ground just moved off the edge of our screen. When that happens, I want to loop this ground all the way around and put it on the end of the second ground element. So what we can do is we can come in here with another increment custom property of our ground with the left here, and I can put 600 as the value. The reason I'm doing that is because I essentially want to take this -300, add 300 to it, and what that would do is make it so our ground is at the very start of our screen. If I add another 300 to it, it's going to make it so that this ground element is now after our second ground element. Now our ground elements are going to be constantly looping around each other. If I just increase this speed here a little bit, we're just going to set it to 0.2 so they move really fast. You're going to notice nothing's working. We need to make sure we import this get custom property. There we go. So now you can see our ground is moving incredibly quickly, but you'll notice we're never running out of ground. It's constantly looping itself back around. If we change this back to 0.05 and make sure that this is there, and if I just inspect our page and I hover over one of our elements for our ground, so let me just come in here to our body, I'm going to find our world, and you can see we have our ground. You can see when I hover over one of these elements, you're going to see that the ground meets up with the first ground element. So both the ground elements meet up directly with each other. So this ground element is moving along, and the second ground element meets up exactly with it. And you can see these left properties are moving, and as soon as one gets to -300, essentially the value of that one is going to be moved 300 away from the first one. So it's just creating a perfect tape that's going to be looping around forever and ever, and we never run out of ground. Now there's one last thing that I want to do in this ground file here, and that is I'm going to pass in a second property called a speed scale. And this speed scale is going to be the scale of our game because as we go along, I want the game to speed up to get harder and harder. That's how the normal dinosaur game works. So this speed scale is going to be a value that constantly is increasing. It starts pretty small, but it's going to constantly increase, and the game is going to get faster and faster and faster as time passes. So what I want to do is I just want to take our speed scale and multiply it by the other values here. So as the speed scale increases, it's going to mean that we increase the speed at which we move our ground, and we increase the speed at which we move everything else in our game. So in our script, we can pass in our speed scale, which for now, I'm just going to pass in the hard-coded value of 1, and you'll see it moves at normal speed. If it's 2, for example, it now moves twice as fast, and so on. We're just going to keep it at 1 for now. So right now, you'll notice that when I refresh my page, the ground immediately starts moving. There's no chance for me to press the any key to start. So what I want to do is I want to create an event listener on our document. We're going to call it add event listener. We're going to call it key down, and this is just going to be called handle start. We're going to make sure that this only runs one time so that we can only actually make this start function run once. Otherwise, every time we press space to jump, it's going to call the start function, not quite what we want. So whenever we press any key, we're going to call a function called handle start. This handle start function will just come down here, function handle start. And in here is where I want to start our loop. So I'm going to put the window.request animation frame inside of here. Also, I want to make sure our last time here is equal to null, just so that we have the first update call, making sure that our last time is null, so it's going to update properly. That way, when we lose and restart the game, it's making sure everything starts from scratch at the very beginning. Also, in here is where I'm going to call the setup ground function. I'm going to come in here, setup ground. Now, when I save, you'll notice our game doesn't start, but when I press a key, now our ground starts moving. So it's hooked up to this handle start function right here. We can also handle our speed scale inside of here. So we can say like speed scale is equal to 1. And up here, let's create our speed scale. And then inside of our update, we can pass that speed scale into here. Then we can create another function that updates our speed scale. So we could say update speed scale. And inside of here, we pass our delta. And we could just create that function down here. Update speed scale takes in delta. And this is a really straightforward function. We're just going to take our speed scale. We're going to add onto itself our delta times our speed scale increase. And this is just a constant variable that we can define up here that defines how quickly our game is going to speed up. So we can say speed scale increase is equal to, and we want this to be a very small number. I'm going to set it to 0.00001. Now when I save, you can see that not quite everything is working right away. So let's inspect our console to see what errors we have in our console. We have no errors, and that's just because I forgot I need to hit space to start. You can see the game starts out at a normal speed, but over time, slowly, it's going to get faster and faster and faster. And it's a little bit hard to see because our speed scale is pretty slow. It's not going to be getting that much faster to start with. So if we just increase this a little bit by removing a 0, for example, and now I press space to start, you're going to notice it starts off slow, and it's going to quickly ramp up faster and faster and faster until it's flying across the screen so quickly you can barely keep up. And you should already be able to see it's getting a lot faster than it was before. And obviously this is getting way too fast, way too quick, which is why I had the speed scale with 4 zeros and then a 1, and that gives it a nice gradual difficulty increase. Now, while we're at it, we can also take our score into account. We can create this update score variable, which takes in a delta as usual. Let's just create our score variable up here. And then we can reset our score to 0 every single time that we call handle start. And then we can just create that update score variable, taking in our delta. And here, essentially, I want our score to be 10, like our time that's passed divided by 10. So we can just say score plus equals our delta times 0.1. This is actually, let's make it 0.01. So for every 100 milliseconds that passes, we get 1 point. So for every second, we get 10 points. And that's going to be our update score. And to actually update the content of our score here, we can just take our score element.text content. Make sure I spell this correctly. There we go. Score element.text content is equal to math.floor of our score, just so we don't have any weird decimal fractions. And we can get this score element way up here by just saying score element is equal to data score. And then inside of our HTML, we can put that data score on our score. Now, hopefully when I press a key, you can see our score counts up, and every second we're gaining 10 points. And that's just going to go on forever and ever until we lose the game and we stop counting the score. Another thing you'll notice is we're not hiding the start screen. That's probably something we should do. So let me just add a data start screen onto here. Inside of our script, what we can do is we can get that start screen element, which is data start screen. Then if we scroll way down here to our handle start, we can just say start screen element .classlist.add, and we're going to add that hide class. So now when I click start, you can see it gets rid of that. And if I refresh the page, it's going to come back. Now that pretty much handles a lot of the foreground. We have our score, our title screen, our ground. The next thing I want to work on is the interactive part, which is going to be our dinosaur. Let's create a simple dino.js class, or a file, I'm sorry. In our script JS, what we can do is we can just import that file, and we're going to have an update dino, and we're going to have a setup dino, just like we did for ground. So we'll say setup dino, make sure that comes from dino.js. Then we can call update dino, pass it in our delta and speed scale. And then down here, we can call setup dino just like that in our handle start. Now we can actually create those functions inside of here. So export function setup dino, and we can export a function called update dino. And this takes in a delta and a speed scale. There we go. And then inside of the update and the setup, we can do all the code we need to position our dinosaur and make it move to the right and jump up and down and so on. Now, the very first thing I want to do is just set up a couple constant variables at the very top of our screen. The first one is going to be for our dinosaur element. A dino element equals document.query selector of data dino. I spell that data. And then if we just go over to our index.html, obviously we're going to add that onto our dinosaur, data dino, just like that. Now what we can do is we can use that dino element inside the rest of our functions. Also, I want to create some variables for our different constants. So we're going to have like our jump speed, for example, which I'm setting to 0.45. We're going to have our gravity, which I'm setting to 0.011. And these are values that I spent a lot of time tweaking to make the game feel pretty similar to the actual original game. You can change the gravity by lowering it or raising it, change the jump speed by lowering it or raising it, and you can really change the arc of the curve of the jump and make it longer or shorter or taller and so on. That's entirely up to you. I just found these values look and work pretty well. Next, we need to set a variable called dino frame count. We're going to say dino frame count, and we're going to set that to 2. And the reason we're doing this is because in our images, you'll notice we have 2 animations for our dino. We have this one and this one. These are our 2 different frames of our animation for our dinosaur running. So we have 2 of them, which is why I set the frame count here to 2. We can oscillate between these 2 different animation frames, and it's going to look like our dinosaur is moving, even though it's just 2 static images being changed between. Also, we can set our frame time. We'll say frame time. I'm going to set that equal to 100. So it's saying that every single frame of our animation should last 100 milliseconds. So every second, we're changing our animation 10 different times. Now we can actually do all the code inside of setting up and updating to make our dinosaur work. So in our update, we essentially have 2 different functions. We have a handle run function, and we're going to have a handle jump function. So let's create those. We'll say handle run, and we're going to say handle jump, just like that. For our handle run, that's where we're going to be moving through our different animations for our dinosaur moving. So in handle run, what I want to do is I first want to say, hey, is the dinosaur jumping? So we'll say if it is jumping, which is a variable that we can create. So by default, we're going to set is jumping to false. And then up here, we can just say let is jumping to create the variable. And then in our handle jump, we can change that. So if the dinosaur is jumping, obviously we do not want to change their animation. We want to set them to the stationary animation. That's how it works in the original dinosaur game. So I can say dino element dot source equals images slash dino stationary dot jpeg. This is just putting us to the stationary image because when it's in the air, that's the image you get when you play the actual dinosaur game. And then we return. We don't want to do anything else. If we're not jumping though, then we want to oscillate the animation. So we're going to create a variable called current frame time, and we want to check to see if that's greater than or equal to our frame time. Oops, frame time, just like that. And this current frame time is something that we're going to be incrementing every single time we go through this function. So current frame time here, we're just going to add in our delta times our speed scale, so that as our game gets quicker and quicker, the dinosaur is going to move faster and faster, so the animation will play faster. So here we're going to pass in that delta speed scale. And up here, we're going to do the exact same thing. Make sure it gets passed in. So now what happens is we're saying every single time that we call this function, we want to update our current frame time by adding in our delta times our speed scale. So it's going to be getting faster and faster as our game goes. We're going to count faster and faster so our animation changes faster. Then, once our current frame time becomes larger than our frame time variable, which is set to 100, what I want to do is I want to swap the frame to the other dinosaur frame. So I can say that a variable is going to be called dino frame. This is our current dinosaur frame. So by default, our dino frame is going to be set to 0, for example. And up here, we can say let dino frame, just like that. So we're going to take our dino frame and we're going to update it. So we're going to take our current dino frame, modulo here, +1. Then we're going to do a modulo of our dino frame count. So what this does is it's saying, hey, our dino frame that we're currently on, which in our case is 0, add 1 to it so our frame is now 1. Then what we're going to do is we're going to modulo that against our dino frame count. So imagine that we had 10 frames total and we're on frame 0. Then the next frame is going to be 0 plus 1. That's where +1 comes from. Now we're doing 1 modulo 10. And that's just saying that if we have, for example, frame 20 and we have a total, or I'm sorry, let's say we have frame 15 and there's a total of 10 frames in our animation. 15 modulo 10 is going to give us 5. So it's going to make sure that we run frame 5 of our animation. Just make sure that our animation loops. So when we go from the last frame, it's going to loop back to the first frame for us automatically. That's all this does. This updates our frame to the next frame. And then we can take our dino element, take the source of it, and we can get our image for that frame. So images/dino run dash, and then we just want to pass in the dino frame dot png. And the reason for that is if I look over here in our images, we have dino run dash 0 and dino run dash 1. These are our 2 frames of our animation, and our dino frame value here is going to be either 0 or 1. So we can just kind of loop between them that way. Now the final thing we need to do is we need to take our current frame time and we need to subtract this frame time variable from it to make sure that we reset it essentially. That it's going to go back down towards 0 and then it's going to start counting up again for us to change the frame again in another time. Now we can save this and you'll notice nothing is really changing right now, but when I click a key to start, of course we're getting an error. Let's see what that error is in our console. Current frame time is not defined. Well, let's define that variable. By default, right here, we're going to set it to 0. And then inside of here, we can say that. So we can just define our variable, and by default, it's 0 during setup. Now when I press a key, you notice our dinosaur is moving. It is actually walking, and it's playing the animation. And if isJumping was set to true, for example, now you'll notice that we don't actually get our animation. And right now, it just doesn't quite look right. Like nothing is working right at all. So clearly, we have something wrong with our code. This should probably say .png instead of JPEG. Now you can see that our animation looks like it should, because in the air, when we're jumping, we don't want to play an animation. But when we're not jumping on the ground, we want to play that nice animation. Now we can get to the hard part, which is going to be handling our jump. This is going to need to take in our delta. So let's just pass in the delta here and there. And then down inside of here, first I want to say, hey, are we jumping? Because if we're not jumping, so if isJumping is not true, then return. Only handle jump if we are jumping. That's pretty self-explanatory. Then what I want to do is I want to take the bottom position of our dinosaur and I want to move it upwards or downwards depending on what my velocity of the dinosaur is. So the way our jump is going to work is when we first start our jump, we're going to set our velocity to an upward value, which is going to be our jump speed here. And then as time passes, we're going to be essentially subtracting our gravity from our velocity. So as our dinosaur moves upwards in the air, it's going to get slower and slower as the velocity starts to reach 0. And then as velocity reaches 0, the dinosaur is going to start moving downward because the velocity is going to become negative because gravity is pulling it back downwards. So inside handle jump, what I want to do is I essentially want to first take our y velocity. We're going to have a value called y velocity, which is going to be by default set to our jump speed when we jump. And what I want to do is I want to increment the bottom of my dinosaur by that amount. So we can call that increment custom property, which we have imported up here. Make sure it just has .js at the end. And I want to increment this for our dino element. I want to increment the bottom position of my dinosaur. What I want to do is I want to take that y velocity variable multiplied by our delta, and that's going to be what I increment by. Then what I can do is I can see, hey, if getting our custom property, which again, make sure we import that up here, get custom property. If getting the custom property for our down or our bottom of our dino element and bottom, I want to say, hey, is this less than or equal to 0? So less than or equal to 0. If so, we obviously don't want to move down anymore because we'd move past the ground. So what I want to do here is I want to set our custom property for our bottom to 0 because obviously it can't go below the ground. So our bottom here is going to set itself to 0, and then isJumping is going to set itself to false because once we touch the ground again, we are no longer jumping. Then I'm going to take our y velocity and I'm just going to subtract out our gravity. I'm going to make sure here I multiply this by our delta. So it's going to scale again with our frame rate. And up here, we need to make sure we make this a little bit smaller. Let's try it like 0.01 to see how that looks. Or maybe we'll try like 0.015. There we go. So now we save. This is looking pretty good, but we have no way to set our y velocity to jump because right now you can see it's working, but we're not actually jumping. What we need to do is create a function called onJump. This is going to be an event listener that plays whenever we click on a key. And in our case, we care about the code for the spacebar. So if we're not pressing space, then we just want to return. And also, if we're currently jumping, don't do anything. So if isJumping is true, also return. You can't jump when you're already jumping. That would be terrible. So then our y velocity here is going to be equal to our jump speed, like I said, and isJumping is going to be set to true. Now we just need to hook up this onJump by using an add event listener. So we can say dino element. Actually, this is going to be document.addEventListener on key down. And what we want to do is add the onJump event listener. And we also want to make sure that we remove this event listener also, because every time that we lose the game, we're calling setup again. So we need to first remove the event listener in case there already is one, then we're going to add it back. So now what I can do is I can click space and our dinosaur should jump, but as you can see, it's not doing anything. If we come and we inspect our page, you can see that it looks like in our console y velocity is not defined. That's because obviously in here, I didn't create a y velocity. So let's do y velocity. By default, our y velocity here is going to be set to 0. And also we want to set the custom property for our dinosaur, which is going to be the down property. So whoops, dino element for our bottom here. We want to default this to 0 as well when we set up our dinosaur. So now let's make sure we import this set custom property. Now when we save, click space, you can see our dinosaur jumps up in the air. And when it jumps, it doesn't have the run animation. And then on the ground, it does have the run animation. So that looks pretty smooth. And I think it works like I would want it to. Now we have our dinosaur moving across the screen and jumping. The animation is playing. It gets faster as the game goes on. Overall, all of this looks really good. Now we essentially move on to the final thing we have to care about, which is going to be the cactuses, which are the obstacles for our game. So let's come in here. We're going to create cactus.js for our cactus file. And inside of our script, at the very top, I'm going to essentially copy the code. So we have update cactus, and we're going to have setup cactus. This comes from cactus.js, and we're going to call those down here. So update cactus, which is delta and speed scale. And we're going to have our setup down here for our cactus. So setup cactus, just like that. Pretty straightforward. And this is going to be the code that's going to spawn our cactuses on the right side of the screen, move them over to the left, and it's going to despawn them when they move off the edge of our screen. So let's save that, go into this cactus file. We're going to export a function called setup cactus. And we're going to export a function called update cactus. This update takes in our delta and our speed scale. So again, like we did in the last file, I want to create a few constant variables. So the first one is going to be our speed, which we're going to set to 0.05. And it's important, really important, that the speed of our cactus is the exact same as the speed of our ground. Otherwise, they're going to move at different speeds and it's going to look really bad. So we just want to make sure those are the same speed. Then what we can do is we can create our cactus interval minimum, which we're going to set to 500. And we're going to do the exact same thing for a maximum value, which we're going to set here to 2000. Now what these do is essentially an interval for how long between summoning a cactus on the screen. So the smallest amount of time is 500 milliseconds. So half a second between cactuses is the minimum, and the maximum time is 2 seconds between cactuses. We're just going to choose a random value between them, and that's going to be when we summon a cactus. And then finally, something a little interesting is we need to get the world element. We can say document.querySelector, our data world element. The reason we're doing that is because we need to add the cactuses to our screen when we create them, and that's what this world element is going to do. And speaking of creating cactuses, let's do that in our update cactus file. What we can do down here is we can essentially say, if our next cactus time is less than or equal to 0, that means we need to summon a new cactus. And this next cactus time by default, we're going to set to the minimum. So the cactus interval min, and then we can just create the variable next cactus time. There we go. By default, it's going to be the minimum amount of time, so it's going to summon a cactus pretty quickly once the game starts. And then once this reaches 0, then what we're going to do is create a new cactus. And every single update frame, we're going to take our next cactus time and subtract the delta from it. So what this is doing is it's constantly making this value smaller and smaller and smaller, and once it gets below 0, we create a cactus. So let's just call a function called create cactus, pretty straightforward. And then we need to take our next cactus time, and we want to set it to a random number between our minimum cactus interval, so our cactus interval min, and our cactus interval max. And we're going to divide this by our speed scale. The reason that we're doing this is because we want to make it so that as our game gets faster and faster, the cactuses also spawn faster and faster, because if they don't, there's kind of no point in making the game fast. Now let's call that function create cactus and actually write the code for it. It's pretty straightforward. We're going to create a cactus variable, which is coming from document.createElement, and this is just going to be a simple div. And then our cactus, we're going to set a data set of cactus to true. And this is because we're going to use that data set. So we can say like document.querySelector all, data cactus. And this is going to be how we select all of our cactuses. That's why we set this right here. Then what we can do is we can take the source of it. And I forgot up here, this needs to be an image, obviously, because we're moving these as images. And we can set that to images/cactus.png. So it's going to be the cactus image. We can add the class list here of cactus. So add the cactus class list. So it has all the styles from our style sheet. And then we want to add this to our world. So we're going to say append our cactus. Then finally, the important thing is we need to set a custom property. Make sure up here we import that with .js at the end. And this custom property is going to be on our cactus. And it's going to be the left custom property. And by default, we want it to be all the way on the right side of our screen. So our left is going to be 100%. That'll move it all the way to the right side of our screen. Now we can create cactuses and they're going to show up on the right side of our screen. Next thing we need to do is make them so that they move, because right now they just show up on the edge of the screen and never move. Also, we need to create this random number between function. So let's just do that real quick. It takes a min and a max. This function, what we're going to do is we're going to get a random number, and then we're going to multiply that random number by our maximum minus our minimum plus 1. And then finally what we want to do is we want to take our math.floor. This is going to give us just a whole number instead of a decimal number. We're going to add our min here at the end as well, and we return this. So to explain exactly what this is doing, we get a random number between 0 and 1. Then to make sure that number falls between our minimum and our maximum, we first multiply it by the difference between our maximum and our minimum plus 1. And that just makes sure it falls between our max and min, because at the end we add our minimum. So the minimum value we can get is our min. If the random number is 0, 0 times whatever is 0, plus our minimum is our minimum. If this value is 1, 1 times our maximum minus our minimum plus 1 is going to essentially be our maximum value, especially when we add our minimum on at the end here. So that's our random number between, and this math.floor just makes sure we get a whole number instead of a decimal. Now we can actually work on moving our cactuses. So when we select all of our cactuses, we can just do a simple for each cactus, and here we can write the code for moving it. Moving them is pretty simple. We use that increment custom property function, which of course we need to import. So increment custom property. And we want to increment it on the individual cactus we're currently on. I want to get the left property on it. And I want to increment it by some value, which is our delta, times our speed scale, times our speed minus 1. Exactly the same as when we did our cactus. And I'm sorry, this is times -1, just like when we did our ground. Then same thing with our ground, we can do a get custom property, which again, make sure that we import up here, get custom property. We want to get it for our cactus. We want to get the left value. And here we want to see if it's less than or equal to -100. And this means, is our cactus way off the edge of our screen? If so, just get rid of it. We don't need it anymore. It's just going to slow down our game. We're just going to call cactus.remove. Now if our cactus is off the edge of our screen, it removes it. So let's click start and see what happens. You can see we get a cactus and it summoned it, and another cactus and another cactus. And you notice the time between them is pretty variable. It depends, some of them are really quick back to back and some of them are much longer between. So this is a really good variance that we get for our different cactuses, and I kind of like it. If we inspect our page, go over to our elements, look in our body, and we look inside of our world, you're going to notice we have a bunch of cactuses down here at the bottom, but they're constantly being added and removed. You can see we never have more than like 3 or 4 on the screen at once. And that's because once they fall off the edge of the screen, they get removed, which is exactly what we want. So that way we don't have hundreds or thousands of cactuses populating our HTML, slowing down our game. Now the last thing we have left to do is way up inside of here. What I want to do is I want to take our document and I want to get all of our cactuses. We'll say data cactus, and I want to remove all of them. So for each one, I want to call the remove function. The reason I'm doing this is because when we start our game, so like when we lose, there's going to be cactuses on the screen. And when we restart our game, I want to get rid of all the old cactuses. Otherwise, you would immediately lose again. Not very fun to play. So this is just going to get rid of any cactuses that are currently on the screen. So when we restart, they're all going to be completely removed. So now we have all of our code for moving around all of our pieces, jumping and interacting. The last thing we have left to do is just to make it so you can actually lose, because a game you can't lose is pretty boring to play. So to determine if we lose, we essentially want to determine, has our dinosaur interacted with a cactus? So as it's moving along, has it ran into a cactus? To do that, we need to be able to get the dimensions of our cactus. We can create a function called export function get cactus rex. This is going to give us all of the rectangles for all of the cactuses that are on the screen. So we can just come in here, get our document.querySelectorAll for our cactuses. And the reason I'm doing this spread operator here, so I can actually use a fancy array method called map, so I can convert this cactus element into a different value. So I can say cactus here, and I just want to return our cactus.getBoundingClientRect. This is going to give me a rectangle that has like a left, a top, a bottom, a right position for every cactus that is currently on the screen, so that we can actually interact with them all. Then I want to do the same thing for our dinosaur. I'm going to create essentially a similar function that's going to do the same thing. Export function get dino rect. This is just going to return dino element.getBoundingClientRectangle. Now, if we save that, go into our script, we can actually import both of those. We can say get cactus rex and get dino rect. And we can create a simple function called isLose. So let's just say function isLose. Actually, we'll call it check. This check lose function is going to get our dino rect. Const dino rect is equal to. And then in order to determine if they've interacted, we can return our get cactus recs. Get cactus recs. What I want to do is I want to call the .sum array method, which is going to say, hey, if any of these cactuses return true for this value, then we know that we want to return true for the entire .sum. So if any of these functions that we create return true, this entire thing will return true. We want to say, hey, is there a collision between our rect and our dino rect? This is a function we're just going to create real quick. Function is collision. This is collision is going to take in a rect1 and a rect2. And all we want to do is check, does any portion of these rectangles collide? So we can just return that value here. We're going to return rect1.left less than rect2.right. So if our left side of our rectangle 1 is to the left of our right side of our rectangle 2, then they're overlapped in that direction. We can also check to see if our rect1.top is less than our rect2.bottom. Again, they have to be overlapping for it to be considered an overlap. Same thing for our rect1.right. It needs to be greater than our rect2.left. And then lastly, our rect1.bottom needs to be greater than our rect2.top. Now, if we save, if all of these are true, then that means that we have an overlap. And if they're true for any of our rectangles, then we lost the game. So if the check lose function is true, then what I want to do is I want to return handle lose. And the reason I'm doing a return here is because I don't want to call my update function again. I want to immediately exit out of our update and stop updating and call this handle lose instead. We can create a function called handle lose, and this is going to handle all of our losing code that we need to worry about, such as stopping our update loop and then making sure we can restart it again. So the first thing that I want to do is I want to change the image for our dinosaur to this lose image right here, because that's what happens in the actual game. So we can call set dino lose, which is a function that we're going to create for our dinosaur. So up here, we're going to import that, set dino lose. Then inside of our dino, we can export that function. Export function, set dino lose. And inside of here, we just want to take our dino element dot source. And we want to set it equal to the images / dino -lose.png. So when we lose, it should hopefully get the lose image. Also, if we go inside of our script and scroll back down, there's a few more things that we're going to want to do. And we're going to want to do them inside of a set timeout. And this may not be entirely obvious why, but the reason is because as you're playing the game, you're clicking space a bunch of times, right? And if you lose, you may have been clicking space at like the exact frame that you lost. And if that's the case, well, then if we don't put this inside of a set timeout and we add an event listener here for clicking a key to start the game over again, it's just going to automatically start the game as soon as you accidentally clicked that down key or that space key. What I want to do instead is give a 100 millisecond delay, so like 1/10 of a second. That way you can see that you lost, and then it's going to add the event listener, and that way you don't accidentally click the key that's going to restart the game by accident while you thought you were still playing the game. And this is just going to call handle start. And again, we want to make sure this is set to once of true. And then lastly, I'm going to take our start screen. I'm going to remove the class list for hide so that it's visible again on the screen. Now, if we press a key, we're playing along, everything's working fine. We can jump over these cactuses. This one's fine. But if we hit one, like we did here, you can see our score stopped counting. We got that death animation for our dinosaur. And now it says press any key to start. We click it again. And hey, look, we're now started back over the beginning. We can jump and everything is working exactly fine. We hit a cactus and boom, again, everything loses. And that's all it takes to create this dino game clone. If you enjoyed this, you're going to love my Flappy Bird clone. It's linked over here, as well as a Pong clone, which you're also going to love. With that said, thank you very much for watching and have a good day.